great pleasure all to today's showcase event on laboratory analysis. We are delighted to see participants joining us to share, learn, and exchange knowledge on advancing soil science through innovative research and practical applications. Today, we are privileged to host two outstanding presentations. First, we have Dr. Enang Roger Kogge, who is a chemistry teacher at the Ministry of Secondary Education and lecturer at the University of Dschang in Cameroon. He will guide us through his research on models relating soil pH measurements in water, potassium chloride, and calcium chloride for volcanic ash soils of Cameroon. Our next presentation would be delivered by Dr. Willie Herman Cloete. I hope I got the name correct. Postdoctoral research fellow at Noordwes-Universiteit in South Africa. He will address pressing issues in soil science and environmental policy. That is the carbon credit conundrum, with which analytical methods should be used for determining soil organic carbon in South Africa. Both of these contributions represent cutting edge of soil science research, and we are honored to provide a platform where this important work can be shared. We encourage everyone to actively participate, ask questions, and make the most of this opportunity to engage with the speakers and each other. Thank you once again for being here, and let us look forward to an enriching and inspiring session ahead.
My name is Willie Cloete. So I'm from the Noordwes-Universiteit, currently a postdoctoral fellow. Yeah, so I was approached by Dr. Roger and asked to present this specific study. So my entire PhD actually was focused on how we measure, map, and model soil organic carbon in South Africa, specifically for acquiring carbon credits. So this was the first focus of my study, which was about like which analytical method should actually be used for determining soil organic carbon. And as we will see, there will be significant um, influence by which method you actually use. So firstly, just to get the basics out, carbon dioxide and other greenhouse gases are a major problem and ultimately leads to climate change, and soil and soil itself has been known to be a very great storer of these greenhouse gases and other uh, greenhouse gases such as CO2 and carbon monoxide and other greenhouse gases in specifically for the soil, in the soil. So the one thing that has been our topic here in South Africa is the selling of the human units of carbon or carbon credits. So even though the focus has not been that much about the amount of carbon that's being stored in the soil, they are more focused on the amount of carbon dioxide that is not emitted out of the soil into the atmosphere. So, but uh, according to the specific measuring or guidelines, which is specified by Vera or the gold standard, the actual measuring of carbon is also very important, and that is why I'm specifically looking at the ways we measure organic carbon. So these carbon credits need to be accounted for, and that's very important. So we need to know which type of measurement are being used. So currently there are several companies using different methods. Now that is the problem, is that I was actually looking at this document again yesterday, that there is no specification which type of method should be used for measuring soil organic carbon. And we will see how much of a value of carbon credits this will influence, which is like quite astonishing and scary at the same time, especially here from where I am. So just to give a brief literature overview, so the three main methods we have here in South Africa is the total dry combustion, the loss of ignition, and the Walkley Black. So the total dry combustion, also referred to by some people as the Dumas method or the LICO analyzer, basically works on the principle of thermal decomposition of very, very high temperatures and then measuring the gas emitted. So, and then the loss ignition is also by um, actually putting samples into a oven and taking out the or measuring the mass differences of the or of the combustion, and then the Walkley black focus on dichromate, which oxidizes organic carbon. Now, what is important is the disadvantages, is because previous literature and the VERA or the previous, like we said, the verified carbon standard procedure has specified that if available, the total dry combustion should be used because previous literature has shown that this is a very reliable method. However, in South Africa, because it is very expensive, we usually the labs here have Walkley Black more available and the loss ignition, which is actually more focused on soil organic matter. And very important, as you can see at the disadvantages part, there's an uncertainty factor of 0.58. So what that means is that we assume that 58% of organic matter is organic carbon. So that is how you convert, according to the loss ignition method, the organic matter to organic carbon, or vice versa. So obviously, because of these different methods work on different principles, there will be different actual measurements, or that was also what I hypothesized. So the main aim was to determine which analytical method should be used for measuring organic carbon for the further purpose of calculating carbon credits. But at the end of the day, these carbon credits give certain companies money, and we need to make sure that they are accounted for and are verifying it correctly. So objectives were to correlate and evaluate the different methods. We developed credible better transfer functions between the methods. So if I don't have one certain method available, I can switch between I can insert the value and switch between the method, and determine percent recovery factor for the Walkley Black. So it has been shown in the previous literature a lot that the Walkley Black underestimates soil organic carbon, especially in very high organic carbon rich areas. So if we have a recovery factor, it will also be great specifically in South Africa. Okay. And finally, what will the implications then be when you are doing a carbon credit assessment? So all of this, what I'm saying, is comes out of the article I published. So you can find it online by just typing in the title. So if you're not unsure, like if I didn't explain something correctly or maybe missed something, you can always go download the article yourself and go through it yourself. Okay. So the hypothesis said, or the main hypothesis that I stated, is that the total dry combustion is the most reliable analytical method that should be used for soil organic carbon measuring. Okay, so that was the one main hypothesis we were focusing on, like connecting with the aim. So what we actually did is we collected 220 samples from 5 different catchments. As you can see, they are from different provinces here in South Africa. So each specific province or catchment was selected because of specific importance. So if I'm going to go here, you can see that each different catchment has a very ecological significance, and that's why they were selected and part of a bigger WRC or water research group project. Okay, so because they have different soil textures, we also expected different general carbon contents. So as you can see, we just made an estimate that some of these catchments would have very high carbon content, some of them will have very low carbon content. So this is just for some information about the sites. Then what we actually did is we took topsoil measurements and we measured them with three methods. So each sample were measured separately for three methods. Now, because of budget constraints, we couldn't actually do other specific soil characteristics, but we also did take representative samples and we tested them for pH. Let's just see if there might be some inorganic carbonates. Now, I'll get to that a bit later to indicate why that's important. Then we did the regression analysis and created the Pero transfer functions, and that was all done in R. And then because we assumed that the Walkley Black would be underestimating the soil organic carbon, we also determined recovery factors. And finally, we did a carbon credit assessment. So because the carbon credit itself is actually a valid measure of the 1 ton carbon dioxide equivalents, we had to firstly calculate the soil organic stock, which is your soil organic carbon times your bulk density, and then finally your depth. So we took the bulk density standard of 1.3 and a depth of just 30 centimeters because we only looked at the topsoil. So we basically took a standard of the bulk density and the topsoil was the same topsoil, and then we just focused on how would the carbon change, how would this affect the carbon candidate assessment, and then when we get the stock, we actually multiplied that by the molecular factor or fraction of soil of carbon dioxide, and finally we allocated that to a specific value, which is we stated that 1 ton carbon dioxide equivalence equals to more or less $20 for now, like it was just an estimate. So what we found is, as you can see on this graph or this specific figure, is that at every catchment, the LOI method overpredicted or showed more soil organic carbon content for all the catchments, except for the GOCO. And you can see that the Walkie Black also showed the least or the lowest distribution of soil organic carbon throughout all the catchments. So that was very important. And then we attributed the GOCO one, which you'll see now will link to the pH, is that there was a very high inorganic carbon fraction actually associated at the GOCO, and that is because the GOCO catchment is situated near a shoreline, and most of the samples were taken near a shoreline. That these samples have bicarbonates and other carbonates and other basic cations leading to increased pH values as well, and we will see now how that will correlate. So as you can see here, of those representative samples, you can see the pH of the GOCO catchments was very high. And even though we didn't do other chemical analysis, like looking at specific bicarbonates or looking at inorganic carbon, this just shows how important it is to, when you are testing the specific carbons, that you make sure that you actually look at this different fractions and incorporate them when you're looking at even you're looking at total carbon as well. So next, we did some regression analysis, and as you can see that overall, the TDC to LOI or in the Walkie back to LOI had very poor relationships when it comes to the GOCO and the Umgeni. The GOCO because it had very high inorganic carbon, and the Umgeni because it has very high organic carbon. And again, the Walkley Black and the TDC. Overall, the Walkley Black and the TDC in literature has a very strong relationship because the TDC measures the specific carbon dioxide gas, and the Walkley Black dichromate oxidizes the soil organic carbon, that they are usually getting very similar results, and the Walkley Black, and the LI, because of that specific correction factor, and that correction factor is not always correct for every soil type. It is clear that it's very like off when it comes to measuring soil organic carbon content specifically, and rather should be organic matter. Okay. So overall, as you can see there, so even though this period transfer function was created, it would not actually be recommended to use, as because you can see the relationship is with an R squared of 0.61, and if you follow the red dotted line, it's the actual observed versus predicted value. So what you want is you want each value or point to be actually on the line, because you want the observed value from the one value, the one value from the one measurement to be exactly the same as the other. As you can see, some of the LOIs are very over predicting, and some of the TDCs are also over predicting. So with the Walkley Black, the LOI, again, the LOI over predicts a lot, or the Walkley Black under predicts. So there's not a clear indication of what needs to happen, and even though the period transfer function was created, it's not recommended to use. However, this final period transfer function was successfully created. However, I want to point out something very important. So if you look at the blue lines that I put in there, it just shows that after 2.5% of soil organic carbon, you can see that the discrepancy between the two values start to significantly differ from the actual observed line. So when you're looking to actually, argument's sake, you have only Walkley Black values and you want to transfer it to total dry combustion values, that when you have a soil above 2.5% here in South Africa, it would not be applicable, because as you can see, the error starts to significantly increase after 2.5%. So that was just an example of how between at 5% of the Walker Black and the TDC of soil organic carbon, there's already a 1% difference between the actual value and the regression equation that we actually calculated. So just to sum that up, overall, the correlation between the Walkley Black and the total dry combustion was accurate and could be used, but only for soil organic carbon content soils of less than 2.5%. Then the total dry combustion Walkley Black, poor relationship, which we see here at the GoCo, was the 0.56 R squared, as you can see, was likely influenced by the poor or the what do you call it, soil inorganic carbon content, which was not measured, but we can estimate that because of the pH. Then finally, the very high actual values of the total dry combustion and the LOI values was likely due to the overestimation of the carbon, especially of the LOI values. And then the low Walkley Black values was likely due incomplete oxidation, which has been shown in previous previous literatures or various literature. So then what we did is we focused on the recovery factor. So I forgot to mention. So for calculating the recovery factor, we took it that we used the Walkley Black value of the measured sample divided by the total dry combustion times 100. That was for the percent recovery. And then for the recovery factor, we just used the recovery factor divided by 100%. I think I can't quite remember, but it was in the article. So as you can see is that for the recovery factors, it's all more or less the same, around 1.27 for all the values, which is actually what you usually get according to literature and not that different. And we will see now if we use such a recovery factor in terms of actual carbon credit calculations, how much of a difference would this make? So just gonna stand here on this slide for a while. So in actual soil organic carbon measurements in the field, so you would usually go to a specific field, and this or the specific farmer is now implementing specific practices which are decreasing carbon dioxide emissions. So you would need to take an actual sample. So we did not take a composite sample, which is usually recommended by the gold standard or the VSC standard, which I mentioned earlier. So, but if you would take a single sample or even a combined sample at a very high soil organic carbon content specific site, for this argument's sake, you can see how much of a difference would the total dry combustion value be compared to like the Walkley Black. It's almost you can clearly see it's almost $20,000 per hectare difference if you take the same sample and just measure it by two different methods. So the same could be said with a high inorganic carbon. So if we take this same value and we did not apply any acidity or any pre-processing or any pre-treatment of the sample for accounting for soil organic carbon, you can see that the total dry combustion method totally overestimated the carbon credit value, whereas the Walkley Black and the Walkley Black factors were more or less the same there. Yeah, so this just showed like what happens when you take a sample and you can and that sample is just measured at the wrong place or measured with specific method, and this is how much it can differ. So the main things we can take away is that the DCC is the most reliable method, which we found, and from literature, because it can analyze a bunch of samples. It's usually environment friendly, and because if you buy it once and you have the actual method or the actual instrument, it can be cost effective. You're gonna run a bunch of samples at the same time. However, if you need it, you need to buy it. It will be very costly. And again, to account for inorganic carbon, you need an acidic reagent such as HCl or something to account and actually remove that inorganic carbon content to just look at organic carbon. And then finally, so if you want to use the specific period transfer function, you could use, and you just only have Walkley Black values, and you want to transfer it to total dry combustion, you can do it for using that specific equation, however, only for soils with carbon less than 2.5%. So just in conclusion, that we are looking in South Africa at these carbon credits and the selling of these carbon credits. However, they need to be accounted for, and the methods are super important. And as we can see that the alloy, the Walkley Black and the TDC has advantages and disadvantages. So overall, well, as I mentioned, the perotransfer function can be used if you only have Walkley Black methods. And if you use specific methods that have severe significant financial implications. So overall, the TDC is recommended when measuring soil organic carbon here for us in South Africa. However, the Walkley Black is still being used, and you can use it for that specific perotransfer function which I developed. And the LI should be moved away from it personally. However, if the community is only accessible to that, future progress. Once I'm looking to refine the LI method and actually to in future create specific perotrans functions and even specific correction factors for this specific method. I also want to include more subsoil samples. So when you're measuring subsoil, obviously the soil organic carbon will now differ in different soil depth. And also want more samples and to do different statistics such as multiple regression analysis, which is just one example. And that is my story. Thank you.
Thank you, Dr. Cloete, for that thought-provoking research work on trying to really understand and find which analytical method should be used for measuring soil organic carbon. I would invite some questions. So now our audience, you have the floor. Please, if you have questions for Dr. Cloete, you can raise up your hand and then we'll call you. We have 5 minutes for questions and discussions. Hi, Jemima. Please, you have the floor. You can open and then ask Dr.
Good
Willie.
afternoon, the lecture. I just wanted to know what type of soils are you going to use this method for, since you're not using the Walkley Black method for the analysis of carbon, because from your discussion, it's like I had this network problem, but I know what is preferable over the Walkley and Black method. So what type of soils do you think will be more, I would like to put it, this method will be more appropriately used for? Did you get that, please?
Yes, Jemima, we got your question. Dr. Willie, please, can you take
All
it
right.
for us?
Chair, could you just repeat? I couldn't hear that last part.
Pardon?
Could you just repeat
Hello?
that? Just repeat that final part about
Okay, I was trying to, the question with regards to what type of soils would you recommend or will you advise that will be used for this method you said is better off over the Walkley Black method for determining carbon?
So I'm just asking. So, am I correct to ask if you're asking which soil types should rather be done with the Walkley Black and which should done by the TDC? Is that what you're asking?
Yes, because you are now saying that these other methods of analyzing for carbon is preferably over the Walkley Black method, because here in Nigeria we are used to Walkley Black method. So we want to look at use for this like it for these methods to be applied on.
Yes. So for me personally, like here in South Africa, like we would recommend using the total dry combustion, and if it's not available and you need to use the Walkley Black method, it will be applicable to all types of soil as long as the organic carbon is just below 2.5% specifically. If you found that the pH might be high and there might be trace of inorganic carbon, to actually just treat the sample with some acidity, then when you're measuring again with the total dry combustion, it will account, you already counted for the inorganic carbon fraction. So again, to the question, which soil type? So at the moment, I would like to see like the influence of different soil types on the actual values, and that's why I want to do something like a multiple regression analysis or different, even machine learning, incorporate that to maybe train a model or something to understand how is the effect of the different um, parameters of soil, not just soil type, but different characteristics of soils on the actual values that we get.
It's okay. But I don't know. Can we also relate that to our Nigerian soils?
Like obviously, I'm not sure. I have no idea what Nigerian soils are. I mostly work with Southern African soils, and I understand that very well. If we can collaborate and look at the chemistry and stuff, obviously, it will be very nice to see, and if there's a much of a difference.
It's okay. No problem, sir. I wish you would be able to do that because when we are looking at conventional soils, we don't just want to say, okay, just South Africa or just the Western soils, but at least let there be an interrelation.
Hello, Dr. Jemima. I think
Soils.
you're having issues with internet.
No
Yeah.
problem. Thank you,
Thank you, Dr.
sir.
Williams,
I
for the
appreciate it.
response. I would invite our last question from Professor Aziz.
Sorry. Yes, thank you, Eric, and thanks to Dr. Willie. My concern is the issue that relates to recommending TDC, and if this concept is to be more or less upscaled to cover the whole of Africa, I think there's some other component that we need to build into it. Vis-a-vis the cost of getting the equipment that can be adequately used to do the TDC, vis-a-vis the cost incurred when we use working black. And to make this general recommendation, I would have preferred that we do a more extensive and African-wide work to actually see, perhaps, if we increase the number of observations, maybe working black could be seen to actually improve other than what we actually have in your study that is actually confined towards South Africa. So, and this also goes to what we do in laboratory analysis, particularly the African-wide recommendation. There is need for us to collaborate such that we can have maybe a model that fits. It might not fit everybody, but it will to an extent fits some variations that we have in Africa will actually be captured. But lastly, I just want to say that perhaps for this kind of work, we could do some cost benefit analysis to actually say what is the advantage we have per unit cost invested into individual analysis. Because at the end of the day, fine, you say that working black will also be used for some organic matter that is less than 2.5%. But in the research, which of our soils has a considerably high amount of organic matter to be in excess of 2.5%? So by implication, working black, which is more or less a cheaper alternative, will also have its way. If you have a look at it from the angle of cost. So I want to just thank Willie again and wish us well. Thank you.
Thank you, Dr. Aziz. I take your question as more of comment and complementation to Dr. Willie for that interesting work. Dr. Willie, want to thank you for that thought-provoking presentation. I think this discussion can still continue here and also after the today's session. I will invite Dr. Roger, if you can hear me now, to share your screen and then proceed with the second presentation. Thank you, Roger.
Thank you very much. So this is a piece of work that was conducted in Cameroon, more specifically on volcanic ash soils, on pH measurements in various solutions, water, KCl and calcium chloride, and also in various soil solution
Please just move to the next slide. Good. So here we portray some important aspects of soil pH, what soil pH can actually inform us on. It is a very important soil parameter that has in the time been termed the master soil variable. So in this figure, we show some of the very important factors on which pH can inform us on, with the references attached where we can get more information. Next, please. Good. Measurement of soil pH. Generally, we make use of electrodes, a reference and an indicator electrode, to determine the pH of soil. Water or certain salt solutions, as earlier mentioned, can be used. Generally, the aim here is to establish the probable range of pH values which a soil can have in its natural states. Next. Basically, why do we use various soil solutions? In water, for example, it is to get the actual pH of a soil, what we call active acidity, if we are in an acidic medium. In KCl or a saline solution, we get the potential acidity. And all of this inform on the behavior of the soil, more specifically on the reaction of the soil. This can even go further to inform on the charge or the nature of the soil colloids of our soil, just from measuring pH in water and these saline solutions. Next, please. Now, why do we measure pH in various soil solution ratios? As earlier mentioned, in water, for example, where we measure using a 1-to-1 ratio, we are putting the soil in near conditions as in the field. In some documentations, these ratios are selected for conveniency depending on the nature of soil. It is also known that when we use a particular soil solution ratio, this might be coming from recommendations for classification purposes, and so on. There are many reasons why we use various soil solution ratios. Please. Okay. What made us to conduct this study? In Cameroon, for example, this is a study which is not common. Something like this had not been done in a remarkable way. Some people have done such studies, but publications on this are very, very rare. So we decided to conduct this study for a group of soils in Cameroon, volcanic ash soils developed from Mount Koupe in the southwest region. The objective here was to see how we can migrate from one soil solution ratio to another, or from one solution to another. In the event of having many soil samples, for example, where analysis becomes tedious, it is thought that models can be developed that can be used to switch from one parameter to another. This will enable us to estimate pH in a given soil solution or a given soil solution ratio when need be, if at all such models are available. Next, please. So this figure just shows the study area located in the southwest region of Cameroon. In this study, what was done in the field, we collected surface samples in the 0 and 20 centimeter soil layers, which were analyzed for pH in water, calcium chloride, and potassium chloride. And the soil solution ratios that were used were 1:1, 1:2.5, and 1:5. This. Yes, so those are the specifications of what were done. Now, to build our models, next slide please. To build the models, we started by performing some statistics on the data that was collected in the laboratory following the soil analysis. So we performed some descriptive statistics. We conducted some measures of dispersion and measures of central tendency. We did some normality distribution studies. Now we went on to study the variability of pH using various coefficients. Simple linear regression was used to build these models. Data splitting using a cross-validation technique was used to validate the models. Next, please. Good. Model performance evaluation. So we use the coefficient of determination as shown in the equation there. The root mean square error, the mean absolute error, and the index of agreement. More on the use of this can be found in the paper that was published, earlier presented. Thank you, please. So what did we obtain in this study? When we look at the data that was obtained in the laboratory for the various pH measurements, we realized that coefficient of variation was generally low, except for electrical conductivity, a parameter which we deem necessary to measure as well, because we thought dissolved solids in solutions can impact on pH. And we intended in this regard to also see if there was a relationship that exists between pH and electrical conductivity. If we look at the standard errors throughout, they are almost uniform and very low, indicating that the variability was very, very low in the various data set obtained following the laboratory analysis. Next, please. Please, next slide. Yes. Figure 1 here simply shows the distribution of the various pH measurements, pH in the various solutions, and for the specified soil solution ratio. When we look at these figures, generally, all data sets follow a normal distribution. This is a very good starting point for analysis of our data, except for EC, which was a little bit skewed. Next, please. Good. Another thing we considered before diving into modeling was to find out the relationship that exists between the various pH measurements. We realized that for pH water, KCl and calcium chloride, correlations were very reliability of the models can be developed when we associate these various parameters. Please, next. Good. Regression equations developed as clearly seen on this figure tie with the correlation analysis that were previously conducted. Coefficients of determination are very high, and this is a good indication that we can actually pair these parameters when we want to deduce, or when we want to predict a given parameter from another. Next slide, please. Same observation, coefficient of determination very high, association between parameters very strong. The regression equations are shown. Next, please. Cool. Here now we associate these one-to-one line segments with the actual regression lines, and then we deduce the regression equations. In this figure, we show the first 4 regression equations that we use as models to estimate pH in the various conditions. That is, pH in the various solutions shown and the specified soil solution ratios. Please, next. Good. And in this other figure, we are showing regression equations that have been used for the other 3 equations. It is important to mention that for this study, we presented 7 regression equations or 7 models, 6 of them being linear and 1 being non-linear. So, in the figure that follows, please, next slide. Good. In this table, we can see the various predicted equations. The prediction equations, equations we can use to estimate pH for a given solution and a given soil solution ratio. The equation of determination, the root mean square error, and the other model validation tools that we use are hereby presented. From the values you have in this table, it is clearly seen that these equations can be very, very effective in estimating pH in this type of soils, for our study area, of course, and for similar soils. Please, next. Okay, that was just to draw attention to that. Thank you very much. Now, when we use a sample t-test to compare measured values of pH, what we actually got in the laboratory, and what we obtained using the models presented, what do we realize? When you look at the p-value, please go to next so that, great. When you go to the p-value, you realize that at 0.01 confidence level or 0.05 confidence level, there is no difference between pH values obtained in the laboratory and those obtained using this model presented, indicating that these models are very, very effective in estimating pH under these conditions. Next, please. What can we conclude in this study? Results of pH measurements which we obtained in this study clearly show that soil samples had a net negative charge. If you could look up in the general characteristics of the soil, they all have a negative delta pH. Differences in soil pH values in different solution volumes were due to dilution effects. If we want to have more information on this, we can read the integral of the article published. So for the 7 models presented, as earlier mentioned, 1 was non-linear, while 6 of them were linear. Please, next. The established mathematical relationships could be used to convert soil pH data of volcanic ash soil from one soil to solution ratio to another. And this can considerably limit the cost of analysis. Given the simple linear models developed with a hand calculator, we can rapidly estimate soil pH if we are in these conditions. It is quite noting that This study made use of a small sample data set. So what we are recommending for further studies is that we could increase the data set to have far better results. We all know that the number of data set in the statistical analysis greatly influences the results. Please, next. Great, thank you very much. This is the piece of work we intended presenting in this second part. Thanks for your keen attention.
Thank you, Dr. Roger, for this interesting work. I know this discussion have been going on within the sub-community, how we can come up with models to complement soil analysis, because we know some of the costs that comes with respect to soil analysis. And if we can come up with equations, models that can get closer to the reality, I think that is the way forward. And your work is a step in the right direction. Before I invite questions, I would start with mine if I don't see any hand now. So I would start with mine. Dr. Roger, you made mention that this is very good work which can be used for other areas, as you said. I want to know how extensive these soils are, the volcanic ash soils, how extensive are they in Cameroon, and what are their agricultural uses of these soils?
Hello, Eric. Thank you very much for your question. I'll start by letting you know that in Cameroon, volcanic ash soils that are dominated by the andosol reference group are distributed in Cameroon along the Cameroon volcanic line. That is, it spans from the coast of Cameroon in the southwest region through the west region, and it moves up to the Adamawa region. So it covers, actually, we find andosols in Cameroon in 3 of the 5 agroecological regions of Cameroon. The humid forest zone, Mondo-Modal rainfall, the western highlands of Cameroon, and the Sudano-Sahelian region. You see, if we can develop such models, can you imagine the extent these models can have an impact in various agroecological zones of Cameroon? We are talking about 3 out of the 5. So I think it is a study that has its place. It can really be applied in this direction. Thank you.
Okay, Dr. Roger, thank you. My second question has to do with the agricultural use of the soils. What are their uses, the use of the soils in Cameroon? Which crops are they mainly grown on?
In the southwest region, that is in the humid forest zone with monomodal rainfall.
Yeah.
In this agroecological zone, this is where most of the plantations are found. Banana plantations, tea, rubber, oil palm. In the western highlands, we mostly have maize, Irish potatoes, and vegetables. In the Sudano-Sahelian region, we have maize, cereals. In the Sudano-Sahelian region, it is very important to note that in this area, crops that dominate are cereals.
Okay, Dr. Roger, thank you very much. I think you've really answered the 2 questions. I would invite our participants to also come with their questions for you, Dr. Roger.
Thank you. I'll be
If I
expecting.
don't see your hand, you can open your microphone and then ask that now. Yes, I see Professor Aziz. Please, Prof, you have the floor.
Yes. First to thank my erudite scholar and one of the key pillars of the laboratory analysis subgroup, Dr. Roger, for a job well done. Mine is just more or less of a comment. And it's just to appeal to the sensibilities of most of us here on this platform that as simple as pH measurement is, we can see the quality of work that emanated from such work and published in a high impact journal. Small as it is, see the impact it's actually going to make. And then secondly, to say that this kind of work, ordinarily, the volcanic ash soils are basically composed of olefins. Perhaps the behavior of pH could differ. When we talk about, let me use Nigeria as an example. We have alpha soils in this part of the world. We have some of our soils that in very few places in the north, they have some element of vertisol, and down south we have alpha soil. In the east, we have oxides of, the ferric soils. So perhaps the pH measurement in such places could more or less be a little bit behave differently, particularly as regards the model. And this is just to a call on most of us that are soil scientists, that this kind of research, though it is small, but it is informative. And just like the presenter said, that pH is one of the most informative property of the soil. In that instance, I will implore us, if we could more or less replicate this kind of trial in our different regions, and let's see if the models developed by Roger, if it actually work for our own soils. And if that is the case, then we can have something similar to having a model that is more or less, nationally acceptable, continentally acceptable amongst us. So this job is small, but it's very rich. I will employ, if we can do it in our different countries that has a different kind of soils, let's see if it will actually go in the line of the models that was observed by Roger. Thank you all for the audience. Thank you.
Thank you, Dr.
Thank you, Prof,
Aziz. Yeah.
for your comments.
Thank you, Professor Aziz. As the leader of the sub-community, I think, Professor Aziz, it would be very good to take this lead and then try to bring all the experts' minds that we have within the community from various laboratories across Africa to really champion this. I think the last time we had the training, you talked about it, and today too it has come into the presentation, and you are making another assertion to it. So, Prof, please, we'll be very happy if you can champion this course so that we can have this some of these results in Africa for our own good. Thank you, Prof.
Sorry, I have to say this. Maybe I should use this opportunity to appeal to our scientists. There is a job before us for several months back. Our people are not responding. We are even actually doing an inventory of our laboratories.
Yeah.
What are our strengths? What are the weaknesses? I'm just appealing. People to actually help us, because we need to know where we are before we can actually make a move to solve some of our problems. We've been distributing questionnaires for months. People are not responding. So I'm on my knees on everybody. They could please just into our call, and let's move soil science in Africa. Let's move it to another length, to another level, as far as the issue of our laboratory analysis, laboratory control is concerned. We are pleading. Just like you said, Eric, we work on it. I'm sure with Willie and Roger in the group, we can move mountain. Thank you. We won't rest on our house.
Thank you, Prof. Thank you, Prof. I know our participants have also, they would respond to this call. Yeah. I would invite Dr. Willie. If I don't see any hands, then Dr. Willie, you would be our last person for today's session with your question, and then we would round things up. Dr. Willie, please, you have the floor. You can open your microphone. Yeah.
Thank you, Eric. Thank you, Prof, for the compliment and the motivation to help spread soil science in Africa and really make a difference. So this is just a question for Dr. Rogers. So you're almost essentially calibrating the soils almost for that specific pHs with this different methods. So I was wondering, like, do you have are you busy now with other models and other like focusing on other soil types in your Cameroonian regions? Because you just looked at the volcanic soils, but it would be so nice and applicable if you could do do a study on different soils and different soil types, and maybe then also incorporate different properties to enhance the model's predictability or accuracy as well. It's just a thought. Yeah.
Okay. Dr. Willie, thank you so much for your question. Before saying something with respect to that, I would want to start by thanking Prof. Aziz for his comments. And then I'll start from one of his very important comments. Why did we focus only on volcanic ash soils? Because we base ourselves on pedogenetic principles. It is generally known that soils of the same type have similar properties. And so for such studies, it is advisable to focus on a particular group of soils. We conducted a study in Cameroon, more specifically in the Northwest region, where we developed pedo transfer functions for estimating CEC. We used data set from 128 soil profiles, a total number of samples over 300. What did we realize in that study? That when we develop pedo transfer functions using pool data, the equations do not inform us so much. They are not very effective in estimating CEC. When we stratify the data according to soil types, the models become better. When we even go further to stratify the data according to pedogenic horizons, we get very, very effective pedo transfer functions. Coming back to your question. Yeah, Dr. Willie, your question is very, very good one. It is very, very delicate. It's a very, very delicate issue. You see, with the diversity of soils that we can have and the various properties that we can have, let's remain with these volcanic ash soils on which the study was conducted. As Prof. Aziz well mentioned, if you have volcanic soils that are allophanic and those that are non-allophanic, it becomes a problem already. You know that pH generally in soils is influenced by soil colloids. So the fact that the soil colloids are different means we obviously have different pH values. Now, talking about extension of these models, statistically speaking, if we have to extend such studies, we have to make use of a very large data set. It's only through the use of a large data set that we're able to develop a strong model that captures a wide area. Yeah, I think that is what can be done.
Thank you, Roger. I have some few questions in the chat. There is one from Alimata who says that congratulations for the nice presentation. She says that soil pH is an important parameter controlling soil nutrient availability. How can we integrate this model in decision support tools for farmer? There is also a need to validate the model in wide range of soils here. So I think, Dr. Roger, the second question would be, how can we integrate this in this model in decision support tools for farmer? Maybe you may want to respond to that.
Yeah, Dr. Alima, thank you for your question. Please, I will not take the risk to say something I'm not sure of. All I know is that development of decision support tools is something very, very complex. Maybe an expert in the domain might be well placed to see how we can integrate this as a tool in decision support, as a component of decision support tools. However, I think when we develop such models, the best way for us to make them is to present in a way the farmer will look at simple to use. I think that's what I can say for now, but saying how this can be implemented in decision support tools, sincerely, I'm not versed with that, please.
Thank you, Dr. Roger, for your answer. I think we can continue with the discussion even after this session. Our last person will be Dr. Kogge. I can see your hand. Please, you can unmute and then contribute also here.
Okay. Thank you very much, there, Eric, and greetings to everyone. I just wish to address the question of Dr. Alimata. I think that when such models are developed, we usually look for the easiest way to address to farmers' problems. If we consider a model like the Quest model, when we make use of data on soil phosphorus, there is a particular type of phosphorus that is considered within the Quest model. Is it if it is P also? Now, if we have a model that makes use of only pH in water, then we will make use of pH that is measured in water. If we have another one that makes use of pH in KCl, and we don't have data on KCl, we can estimate that if we have data on pH water, and so on. So it's all about knowing what data we have, what we don't have, and what we can estimate. Thank you. I just wanted to give that little contribution.
Thank you, Dr. Kogge. At this point, I don't see any hand again, and I think we've come to the end of today's showcase event. I would like to thank everyone who joined today and contributed in making this session a success. And also special thanks to our distinguished speakers, Dr. Roger and also Dr. Willie, for your thought-provoking presentations. I know your presentations have deepened our understanding of soil science and also highlighted some of the real-world implications of laboratory methods in advancing sustainable agricultural and environmental stewardship. I'd like to thank all participants for your engagement and thoughtful questions, and also our commitment to learning. It is true, as Professor Aziz mentioned, that we need a spirit of collaboration and knowledge exchange in our community so that we can grow stronger. I know as we live, we carry forward the insights we have gained and continue to support each other in building innovative solutions to the soil exchanges, to the soil challenges we face globally. We look forward to welcoming you to our next event next month. Until then, let's stay inspired, let's stay curious, and let's keep working together for healthier soils and a more sustainable future. Thank you and have a wonderful evening.